Alright, our new topic now is on data transformation. Right, now remember the whole process of bivariate data and statistics was that we drew a scatter plot. We tried to find out whether there was a strong positive or negative linear relationship. We confirmed whether it was linear or non-linear. If it was linear, we did a residual plot to confirm that it was linear. And when we did that, we worked out the regression line for that question. So that was the whole process you have been working with so far. But what happens when we want to try and confirm linearity and it becomes non-linear? So you've done your residual plot, you haven't got a nice random pattern that confirms linearity, but you've got like a crest or a valley. What happens when you have a crest or a valley? It's a non-linear relationship that has been graphed. So what happens then? Now what happens is we have to transform the data to make it linear. And the only way you can do this is by working with the data via the x-axis or the y-axis. So we play with the x values or the y values, and we either stretch the data or we compress the data, right? And we're going to concentrate on three ways to do this. And the first way is the square transformation, the logarithmic transformation, and the reciprocal transformation. So if I'm doing the square transformation, what I mean by the square transformation is that if I'm looking at my x values, right, I'm doing an x squared transformation. The square transformation is whatever my values for x were, they are now going to become x squared. The log, whatever my x values for x were, I'm going to log them now. So I'm doing log x, and the reciprocal would be 1 divided by the x value. So this is the transformation that's needed that we were talking about. That's what I'm talking about, actually. So let's have a look at a situation, what happens here. Now, all I'm concentrating on here is transforming the x-axis. We've got to repeat this whole process for the y-axis. So here, transforming the x-axis. Now, what happens is we're trying to linearize a relationship. So if you get, like a curve like this, or a curve like this, or a curve like this, or a curve like this, when do I use the appropriate transformation for that? Now, we can do this by transforming the x-axis first. Then, if a situation happens, we can transform the y-axis as well, depending on the situation that we're dealing with, okay? So, what happens when we transform the x-axis? When you transform the x-axis, it will have an effect that it moves the x values on your plot horizontally. That's all it does. And nothing happens to the y values. The y values do not change. Okay? So if you do an x squared transformation, this is what happens. If you do a log x transformation, this is what happens. And if you do a reciprocal transformation, this is what happens. Now, what do I mean by this? So for example, if your graph, I'll pick purple here, and I'll just make the line a little bit thicker so you can see what I'm talking about. If your graph looks something like this, a nonlinear graph, and it's curving like this, right? You do an x squared transformation, you'll get a straight line like this. Okay? If your graph looks something like this, like a curve, I'm missing them, but you get the point. Your log x transformation for the x moves the points towards this straight line here. And if you happen to get a graph like this, so I'm looking at a graph, whoops, sorry, right? What ends up happening is your points move that way when you do the reciprocal. So it's more like a twist. You're twisting here. So this is what happens when you do the transformation, but how does it work? Let's have a look at an example. Alright, here's example 3. Example 3 says linearizing the relationship with a 1 on x transformation. So I'll do 1 and then you can play around with it later. Now here are my x values, here are my y values. Now if you go ahead and plot those points, right, just go and plot those points and tell me what you see. This is what you get. You get a graph like this. That's those points plotted. So here you can tell me that this, just from the graph, that this is non-linear. linear. It's a nonlinear graph. Now, in order to linearize this data, I can do an x squared, log x, or a 1 on x transformation. Now, if I go back to the question, they are telling you to apply a reciprocal transformation. So they're telling you to do 1 on x. Now, if you've got x and you've got 1, 2, 3, 4, and 5, they are telling you, forget what x, we want you to do 1 on x. So 1 on x would be 1 on 1, 1 on 2, 1 on 3, 1 on 4, and 1 on 5. These are our new x values. So they want you to plot these values versus the y values above. Remember we said they're unchanged. So here you're going to plot, well, 1 on 1 is 1, everyone knows that. And your y value here is 15, 10, 7.5, and 6. Alright, so this is what we want to plot now. This was the old graph. This is the new graph. And when you go off and plot that, this is what happens. You get a nice linear line. And that's not a straight line. So I'll undo that. And I'll put you a nice straight line, just so that you can see a nice straight line here, and so that Mr. Eddie can draw a straight line. And now you notice it's become linear, right? So here, the transformation of a 1 on x has made this graph linear. Fantastic. This is what we want to do. So when to do what is this scenario over here. So what sorts of nonlinear relationships can we linearize using the x squared transformation? So ignore all of this writing here for the moment. I'm doing an x squared transformation. When do I do an x squared transformation? When do I do it? Okay, so let's look at x squared transformation. This is what I'm looking at here. This one here is when do I do a log x transformation, and when do I do a 1 on x transformation. And it's pretty straightforward, people. Very, very simple. If you're not always true, most of the time, if your graph looks like that or like that, use x squared. If it looks like this or like this, the most appropriate to use is a log x transformation. And if your graph looks like that or like that, alright, so these are pretty much the same. If you can see up here, they're pretty much the same, except can you see how these points curve out a bit more towards here? Right, this one's pretty much the same. So this transformation would be 1 on x. Okay, so these two are a bit touch and go. However, this situation is okay up here. Now this is only for x axes, and next lesson we'll look at transforming your y and when to do that. But at the end of it all, I'm going to give you something that's really neat, like something called the circle of transformations, which I'll explain next lesson. So see how you go with those exercises now.